Hi everybody, this is Chapter 2, Section 5 on deductive reasoning. So in here we'll look at two different laws of deductive reasoning, the law of detachment and the law of syllogism. And this is for Math 211, Elements of Geometry. The first thing we're going to do is just review quickly a conditional statement, which we talked about in the last two sections. And remember, your conditional statement is your if-then statement. So if P, then Q. The converse to that would be if Q, then P. The inverse is if not P, then not Q. And the contrapositive would be if not Q, then not P. All right, in the past sections, we talked about inductive reasoning, and we talked about how you look at specific things and make a generalized conclusion. And I talked about the example of how my daughter said, because her little sister started preschool on September 10th, everybody or all the preschools must have started on September 10th. So she took that one specific example and made a generalized statement, which lots of people tend to do. They look at a little bit of information and make a generalized statement. Deductive reasoning is a little bit different. Deductive reasoning is the process at arriving at a specific conclusion from one or more general statements. The conclusion is proved, or a conclusion that is proved by true deductive reasoning is called a theorem. So when we have our theorems, they've been proved through deductive reasoning or through reasoning. Now, deductive reasoning would be something like if we have a general rule. If a number is, if an angle measure, let's say, is less than 90 degrees, then the angle is an acute angle. So that's a general statement. There's lots of angles that are less than 90 degrees. But then, so using deductive reasoning, I take that general statement of if an angle measures less than 90 degrees, then it's an acute angle. And I can say, well, then a 10-degree angle is an acute angle. And that specific answer is going to make that deductive reasoning. So I took a general statement that covers lots of things, and I made a specific conclusion about an angle that measures 10 degrees being an acute angle. So deductive reasoning, I want you to think, it goes from general to specific. All right, and here we just have a slide to compare or look at both of them. And again, inductive reasoning, we're observing patterns and examples, and we're making a conjecture. And you go from specific to general. Deductive reasoning, you take a general statement and then make a specific conclusion from that statement. Okay, so here I have 4 statements, and I want you to decide if the statement is inductive or deductive reasoning. So read them over and look to see if it's inductive or deductive reasoning. Pause the video, write down your answers, and then when we come back, we'll check it. So give it a second, pause it, and then when we come back, we'll check. Okay, so hopefully you read through the examples and you decided if they were inductive or deductive reasoning. So the first one, after an examination and a diagnosis of several patients, a pediatrician concludes that there's an influenza epidemic in the area. So here, they diagnosed and examined of several patients, so 3, 4, 5, and then they concluded that there was an influenza epidemic in the area. So again, this one went from specific to general. So that means that this would be inductive reasoning. All right, so for the second one, if an integer is even, then it is divisible by 2. Since 14 is an even integer, it is divisible by 2. So here we start off with a general statement. If an integer, which is a pretty, an integer is a pretty big, there's lots of integers out there. So if an integer is even, then it is divisible by 2. So that's a general statement. And then we go to a specific example. Since 14 is an even integer, it is divisible by 2. So this, because we went from general, to specific, this is deduction. Can't write today. All right, let's take a look at the third one. If two angles are complementary, if the sum of the measures is 90 degrees, if one of the two angles measures 50 degrees, you can conclude that the second angle measures 40 degrees. So again, we start off with a general statement. If two angles are complementary, then their sum of their measures is 90 degrees. That could mean millions of different angle pairs. And then they go to a specific answer. One of two angles measures 50 degrees, then you can conclude that the second one measures 40. So this again would be deduction. All right, and then our last one, Bill, who works on a production line, has assembled at least 40 units every day for the past week. You can conclude that Bill will assemble at least 40 units again today and every day this week. So here they're taking this one would be inductive. He assembled 40 units every day for the past week, so they looked at each day in the week. And now we're saying, well, in the future, today and this week, he's going to assemble 40 units. So this one, it's a little bit harder, but this one is induction. We go from a specific example to a general statement. Okay. Now, I did mention earlier with our deduction, we're going to look at two laws. The first is the law of detachment. And the law of detachment says if P, then Q, is a true conditional statement, and P is true, then Q is true. That's what our law of detachment says. Here is you can write it different ways, but here's kind of how to look at it. So you're going to start off with two premises and then a conclusion. The first premise is your conditional statement. So that is if P, then Q. Okay. Then what you're going to do for the second premise is they're going to repeat P. So they're going to talk about P in some form. And then the third part is you're going to have a conclusion, and that is going to be Q. Now, if all of these are true, then it's a valid argument. It's considered a valid argument. It has to follow this order. If it doesn't follow this order, it is not a valid argument. So for instance, we could have a conditional statement, if P then Q. But if instead of repeating P, they repeat Q, and then they repeat P for the conclusion, which those three dots mean therefore, then it is not a valid argument. So this would be not valid. So here we're going to take a look at our law of detachment and see if we can make a conclusion. Here, they gave us our conditional statement. So if you shop at Save Market, then you will save money. So this is our conditional statement. They repeated P. So you shop at Save Market. So your conclusion would be Q, you save money. So this is a good example of our law of detachment. All right, so here what we're going to do is determine if our argument is valid or not using our law of detachment. We're always going to assume that the conditional statement is true. So here, if any student gets an A on the final exam, then the student will pass the course. Okay. So then P, remember, is any student gets an A on the final exam. Q is the students will pass the course. Leo got an A on his final exam, so they repeated P. Now, they didn't just say any student, but they named a student. So our conclusion here is he will pass the course, which is also our Q. So because it goes from our conditional, if P then Q, form, then they repeat P and then Q, it is a valid argument. All right, let's take a look at B. If two angles are adjacent, then they share a common vertex. So here is our P, and here's our Q for this statement. Next, we have angles 1 and 2 share a common vertex. So if we look, that's going to be Q, and then so the angles are adjacent, and that would be P. Because it doesn't follow the format where we have the conditional statement, they repeat P and then Q, this is not a valid argument. So this would not be a valid argument. All right, so the next law we're going to look at is our law of syllogism. It's a little bit different than detachment, as with detachment we had one conditional statement and we broke it down into two parts for the second two parts. Here we have three different conditional statements. First, if P then Q is true, and if Q then R is true, then if P then R is true. So really what we're doing is we're taking two conditional statements in the beginning. We're taking if P then Q and if Q then R. If they are both true, then that means if I take what I call the beginning and the end of the two conditional statements, put them together, that will also be a true conditional statement. I also call this like kind of cutting out the middleman. You're cutting out Q for your law of syllogism. Okay, so here's a good example of the law of syllogism. We start off and we are given if a figure is a square, then the figure is a rectangle. So if a figure is a square, this is going to be our P. Then the figure is a rectangle. That's going to be our Q. Then you'll notice down here, if a figure is a rectangle, so they're repeating Q here, so we have another Q. Then the figure has four sides, so that would be R. Now, the conclusion, remember, what we're going to do to write our conclusion is we are going to take and combine P and R. Since Q is the same in both, we're going to, like I said, kind of cut out that middleman and put P and R together for the conclusion. All right, so again, they have the diagram on the other page. Now what we're going to do is just write our conclusion. And we said we're going to take P and R and put it together and cut out our Q, our middleman. So our conclusion would be if a figure is a square, then the figure has four sides. And that would be our conclusion using our law of syllogism. All right, so here they give us an argument and they want us to give the conclusion from the argument, and is it the law of detachment or the law of syllogism? So for our first one, they give us, we have all elephants are mammals, all mammals have hair. And I want you to think, what would be a good conclusion to that? Is this going to be the law of detachment or the law of syllogism? Now I know it's not really written in conditional form, but we could put it in conditional form. If an animal is an elephant, then it is a mammal. If an animal is a mammal, then it has hair. So here, if you notice, we have two different conditional statements where they both talk about mammals as our Q. So this one would be your law of syllogism, and the conclusion would be all elephants have hair. Okay, and our last one here. We are given, if a number is prime, then it has exactly 2 factors. The number 11 is prime. So here, if you note, we have one conditional statement. We have P, and then we have Q. P is a number is prime. Then they give us 11 is prime. So that's going to be repeating P. So this is going to be our law of detachment. And remember, your conclusion will be Q. So the number 11 is prime, so our conclusion would be then it has exactly 2 factors. All right, that is it for 2.5. Have a great day, guys.